surface exploration based on reinforcement learning, locomotion, polish. And first, we have some background. Now the naked robot have achieved good motion ability based on abundant perception and high precision control. But most of the time, the computation consumed is merely kept in the control body balance or a certain posture, just like not falling down. However, looking back at nature, many animals without eyes or with poor perception can also move stably in complex terrain. They mainly rely on 2 points, the highly adaptable body structure and the involved nature neural network controller. Therefore, we wonder whether we can reduce the demand for the control algorithm of the body balance by designing a novel bionic structure and adopting new sensing method to reduce the demand for sensors. Meanwhile, using neural network to control movement, just like what animals do. So in this work, we proposed a spherical multi-layered deformable robot with the Urchin-like structure and adopt neural network control from body touch to joint actuating. Through model-free reinforcement learning, we can achieve autonomous adaptive motion in under complex terrain. Furthermore, we implemented a prototype to verify the method that can be directly transferred to the real world, and its dynamics is feasible. The robot also holds the advantages of not falling down and can move in all directions. We chose the Urchin, which has no eyes and only relies on the photothorns to perceive the environment. Specifically, 12 legs are symmetrically distributed on the surface, on the face of the regular dodecahedron, and we developed a high expression ratio lay and control system finally connected these parts to a whole robot. And the locomotion police network uses a 3-layer perception. The observation state includes leg length, the body orientation, the angular velocity, and the leg ground contact signal. The network outputs the speed control of 12 legs, and the reward function merely reward robot to learn to work from scratch, avoid obstacles, maintain a low impact performance with the ground when rolling, and we first training in simulation and then transfer it to the prototype. For the simulation experiment in the flat terrain, the robot learned the forward gait of a periodic switching and was able to adapt to the slope obstacles and the gravel terrain with the size of 17% of the prototype. After the poison sensing is added, the robot can also recover automatically to the desired trajectory under the strong external disturbance. And in a real-world experiment, we directly deploy the gain to the prototype, which can demonstrate the following movement, like in trauma gait, the unknown in terrain adaptation and the slope adaptation, and also ability of obstacle avoidance. So to conclude, we proposed and implemented the Urchin robot based on a model-free reinforcement learning policy. This will be an all-round bionic robot, which will provide new ideas for embodied intelligence and can also replace humans in many risk tasks like planetary exploration, rescue of earthquake ruins. The more details you can see in the paper. By the way, a little advertisement that I'm actively searching for PhD position in 2023 fall. And if you have any question, feel free to contact me. Thank you.
Thank you, Dan. Thank you, Dan. So